Hi everyone, Assalamualaikum. In this video, we are going to continue with area between curves. Now we look at example 3 from previous semester papers. The figure below shows the region W in the first quadrant, which is bounded by the curve x equals to y minus y cubed here and the y-axis here. Okay. Find the area of the region W here. Alright, to find the area, we can use either formula number 1, integrate with respect to x, or formula number 2, integrate with respect to y. Okay, let me check the first formula first. Okay, alright, when we use the first formula, okay, we need to use top minus bottom. Okay, from here, the top and bottom are from the same curve. So, it is not suitable, okay, to find the area using top minus bottom, right? Because we subtract from the same function, right? So, the first formula is not suitable, right? Or in other words, we not use integration with respect to x in this question, right? Then we check the second formula. Okay. Alright, if we use the second formula, we need to subtract from right and then minus left. Okay. And from here, it is clear that the curve here is the right function and y-axis here is the left function. Right? So means that for this question, we use the second formula. Means we integrate with respect to x, we use right minus left, and we use limit on y-axis. Alright? Alright, so first, we need to find the lower and upper limit on y-axis. Okay? Alright, so first, we need to find the coordinate of intersection point. Okay, here. Okay. And to find the coordinate of intersection point, we need to solve simultaneous equation. Okay. Alright. So let's say we have this line. Okay. This is line x equals to -1. Let's say here, this line here intersect x equals to -1. So this is line x equals to -1. Alright, how about y-axis? Okay, y-axis means line x equals to 0, not y equals to 0. Okay, but x equals to 0 because we refer from here. Right? Alright, so note that y-axis means line x equals to 0. And x-axis means line y equals to 0. Okay? Alright, from here, from line x equals to 0 here, so we have x equals to 0, we're naming it as equation 1. Okay? And then from here, x equals to y minus y cubed, we're naming it as equation 2. Okay? Then we can substitute equation 2 into equation 1. Okay? We substitute y minus y cubed into x here. Because y minus y cubed also equals to x. Right? So after we substitute here, so we get y minus y cubed equals to 0. Right? Then we can factorize. So we get y times y minus y squared equals to 0. To check, we can expand. Okay? Then we will get back the original function here. Alright? Or the original equation. Alright? Then, y equals to 0 or 1 minus y squared equals to 0. So from here, y squared equals to 1. And y equals to square root of plus minus square root of 1. means that we have two values of y equals to 1 and y equals to negative 1. Right? Right, from here, y equals to 0 is here. Okay? Our lower limit. Okay? And then from here, y equals to 1. Okay? Here. Okay, this is y equals to 1. Okay? So means that this is our lower limit and this is our upper limit. Okay, on y-axis. Alright? Alright, for y equals to negative 1 here, okay, since there is no graph at y equals to negative 1 here, this is y equals to negative 1 in this area, okay. So since there is no graph at y equals to negative 1, so we just ignore this value, right? So our lower limit equals to 0 and our upper limit y equals to 1, alright? Alright, from the previous slide, we find the lower limit and upper limit on y-axis because we use integration with respect to y here. Okay, so means we need to use right minus left. Okay, so to avoid error, we can write x equals to 0 here. Alright, so we can clear that this is right function and this is left function. Alright. Okay, then find the area of the region W. Okay. Alright, we choose the second formula. Okay, area equals to integration with respect to y. And when we use integration with respect to y, we need to use lower and upper limit on y-axis. Okay, y equals to 0, our lower limit, and y equals to 1, our upper limit. Okay, on y-axis here. Okay. And when we write right minus left, or when we use integration with respect to y, means all here must in terms of variable y. And to write in terms of variable y means we need to write x as a subject. Okay. Right. And then from here, okay, these are our lower and upper limit. Okay. The values on y-axis because we integrate with respect to y. Alright? From here. Okay. Okay, then area equals to integration from y equals to 0 to y equals to 1. We replace right function equals to y minus y cubed. And then minus. We replace left function by 0. Okay. Note that the subject must be x here. Okay. Alright. Then we simplify, so we get integration from 0 to 1, y minus y cubed. Okay. After that, we can integrate with respect to y. Okay. And when we integrate, no more integration sign. Alright. So we have area equals to, we integrate y with respect to y, so we get y squared over 2. And then minus, we integrate y cubed with respect to y, so we get y to the power of 4 over 4. And then no plus c because this is definite integral, but we need to write square bracket with lower and upper limit. Right? Then we replace upper limit into variable y. Okay? And then in between must minus. And then we replace lower limit 0 into variable y here. So we get 0 here. Okay? Then we simplify. So we get area equals to half minus 1 over 4. And area equals to 1 over 4. And then we must write unit and then square. Square here because area. Okay? So our area for this region here equals to 1 over 4 unit square. Okay? And notice that area always positive value. Okay? if we get area equals to negative value, so maybe there is something wrong when we integrate, or maybe we have something wrong in setup formula here. Alright? So the answer, area equals to 1/4 unit squared. Alright? Coming up next, more examples for area between curves. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.